Hello, today I'm going to show you how to collect a fluorescence emission scan and also excitation scan in the OLIS SpectralWorks software on an OLIS fluorimeter. Um, you can see here we are now on the live displays tab in the software, and when it's in idle mode, that means it's ready to collect data. Uh, I'm going to set up, in this case, for my sample to collect an excitation with the excitation wavelength of 370 nanometers. So I'll go in here and simply type in 370 in both the starting and the ending wavelength. You can change the current wavelength as well over here, but once you start collecting the scan, it will go to this number right over here. For my emission wavelength range, I'm going to scan from 570 to 630, and I'll leave the number of increments as 60. Should you change this number of increments to something else like 100, then you will see that this number here will recalculate, and that is dependent on the grading lines in the monochromator, etc. But I'm going to go ahead and change this to 60 and go with that, and I'm going to leave my integration time at 1 second. In this particular instrument that we're using, the excitation monochromator has automated slits, so you will have to go in here to set the slit width to where you want it to go, unless you set it up to auto adjusting the slits, which you can do over here, and then you will set it to fixed bandwidth, but you will still have to input some value in one of these numbers. In the 45 and the 245 fluorimeters, then there are manual slits on the excitation side. For all these instruments on the emission side, it has manual slits where you can increase or decrease the slit width depending on the bandpass you need for your compound that you're measuring. So I'm now set up to collect my data, and then I will go ahead and just simply proceed with collecting data. Should I instead want to do an excitation scan, then it's in principle it's the same thing. You just change which wavelength range you fix. So in our case, I will now change my emission wavelength to, let's say I wanted to sit at 610 nanometers, but then I want to scan the excitation, and I will go from 250 to 450. And again, here you'll see that it recalculated this ending wavelength depending on this, the number of increments. So I'm going to go ahead and change this to 100, and I will set this to 450. And I'll leave the integration time again as 1 second, and then I will go ahead and proceed with collecting my data.